So the first section of this unit is real numbers. Real numbers are essentially all of the numbers that you can think of that do not include the square root of -1, which is often called I, or an imaginary number. So the real numbers are all numbers that are either rational or irrational and do not include the imaginary number I. I find this Venn diagram pretty helpful when it comes to categorizing real numbers. Real numbers can be divided into two basic sections, the rational numbers and the irrational numbers. Rational numbers can be, they can turn into fractions. So anything that has a finite number of decimal places or repeating decimal places, and that's important, they have to actually repeat, those can be turned into fractions and are therefore rational numbers. Irrational numbers are numbers that cannot be turned into fractions, so that they have decimal places that go on forever and never repeat. Some examples of irrational numbers are pi, which we'll be using later on in Unit 5 when we talk about circumferences and areas of circles. Also, an irrational number would be something like the square root of 2, where there are no two numbers that are rational that multiply to create 2. So the square root of 2 is irrational. Another one is e. E is a number that is used when we're talking about exponential growth. So rational numbers can be further divided into counting numbers, whole numbers, and integers. So the counting numbers are the numbers that we basically learned to count with when we were toddlers. So 1, 2, 3, 4, 5. Positive whole numbers not including 0. So those are our counting numbers. Whole numbers are all of the counting numbers including 0. So whole numbers, the only additional number is 0. So that'd be 0, 1, 2, 3, 4, 5, and so on. The integers are all of the whole numbers as well as the negative numbers. So -3, -2, -1, 0, 1, 2, 3 are all of the integers. And again, rational numbers include all decimals that are either finite or repeating. So let's move on and actually write down some definitions so that we have a good way of remembering these things. You may also see the counting numbers called natural numbers. Those two terms are completely interchangeable. So whenever you see the word natural numbers, you can think counting numbers. So again, the definition is the numbers we learned to count with. Again, the examples are 1, 2, 3, 4, and so on. The whole numbers are the counting numbers and 0. That'd be 0, 1, 2, 3, and so on. Integers are all the whole numbers as well as negative components. So -2, -1, 0, 1, 2, and so on. Rational numbers is a number that can become a fraction. This includes finite decimals, so decimals that have a finite amount of digits in them, and repeating decimals. So again, rational numbers include all of the integers, whole numbers, and counting numbers. So we can include 0, 1, -7, but also include numbers like 1/4, 2/3, or 2/8, whichever you prefer. 1/4 and 2/8 you'll see are the same thing. Also the repeating decimals, so 0.6666666 repeating. And when you see repeating decimals, you will either see the ellipses, these 3 periods after several repeating numbers, or you might see a number that has a line on top of it. So I'll draw one for you. So let's look at 0.1 repeating. So 0.1 repeating, the way it's written here, is the same thing as saying 0.111111111 ad infinitum. Then we have our irrational numbers. Pardon my clicking. So our irrational numbers are numbers that cannot be written as a fraction. And those include numbers like pi, e, like I talked about before, square root of 2, or any number that just goes on forever. So I'm going to type one for you as well. So if we look at the row underneath here, 2.001.001.0001.00001, you can see that there's a pattern there, but it doesn't actually repeat. It just goes on forever, adding zeros before the 1. So there's no way that we could make that number into a rational number. So those are our definitions. Let's take a look at some problems that we have here. Given the numbers 0.583 repeating, 0.47, and 3.6055551275, list the rational and irrational numbers. So we can see the rational numbers, as we said before, are the numbers that have finite decimals. So this guy right here has a finite number of decimal places. It only has 2 numbers in it. So we're going to just type 0.47 because it is a rational number. And then we also have a repeating decimal here, right? So we're going to add that one in too. So that leaves our irrational number as that 3.60555125. Notice the ellipses after this one does not mean it's repeating, because there is nothing that is consecutively repeating in the decimal above. You see 3 5s in a row, but then afterwards there's the 1275. So there's nothing in this number indicating that it's going to repeat at any time. Let's look at the next problem. For each given, identify whether it is rational or irrational. So note that just because it has a square root in front of it does not make it an irrational number. If you happen to know the square root of 36 or just type it into your calculator, it will become 6. And 6 is a rational number, so therefore this one is rational. Square root of 44, however, when you evaluate it in your calculator, is not rational. There are no repeating digits, so this one is irrational. Some of you may note that you can factor a 4 out of there, take the square root of 4, you get 2, but then you'll have 2 times the square root of 11, and the square root of 11 is still irrational. Let's look at problem 3. For each number given, identify whether it's a real number or not a real number. We talked about real numbers at the beginning of the video. Anything that has a negative inside the square root is not going to be real, because the square root of a -1 or the square root of any negative number is going to be imaginary. So this one is not real. But when we look at a negative outside the square root, that is perfectly acceptable. It just that means that we're going to have a negative times whatever is inside the square root. So this is going to evaluate to a -8, which is a real number. Finally, let's look at these given numbers here and see if we can list out which are the whole numbers, which are the integers, which are the rational numbers, which are irrational, and which are real. So let's look at the whole numbers first. So if you remember, the whole numbers are all the counting numbers in addition to 0. So we have to make sure that there's no negative numbers, no fractions, and no irrational numbers. So looking at the numbers that we have here, we have a negative, we have a fraction, we have a positive whole number. So that means that that one is going to be part of our whole numbers. Square root of 5, 5.9, negative square root of 64. Our only whole number in this group is going to be 8. So let's look at the integers. One of the nice things about going in this order is anything that's a whole number is also an integer. So we can add that guy right away. So we remember our integers do not include fractions, but do include negative numbers. So we can add -7 to this list. 14 over 5 is going to be a fraction. We already have 8. Square root of 5 is irrational. 5.9 is a decimal, so it cannot be included in the integers. Negative square root of 64. As we saw up here, -64 evaluates to -8. So we can say that -64 is an integer. So we'll add that to our list. Now, let's look at the rational numbers. So the rational numbers, again, they include our whole numbers and our integers. So we can just throw all of our integers into the rational numbers immediately. Negative square root of 64. But what else can we add to this? So we already have -7. 14 over 5 is already written as a fraction, so we know that that one is going to be a rational number. We already have 8. Square root of 5 is going to be irrational, so we cannot include that one. 5.9 is a decimal, and that can be turned into a fraction, so we can add that guy. And I should clarify, it's a finite decimal, so that's why we're adding it. And then we already have negative square root of 64. So finally, let's look at our irrational numbers. Of which we only have one. So when it comes to the irrational numbers, you can't include the rational numbers because they are mutually exclusive, which means that they do not overlap at all. So we already have all of these numbers listed in the rational numbers, but not the square root of 5. So that one is going to be our only irrational number. And then lastly, it asks us what our real numbers are. And the real numbers are all of the above. Because none of them include the square root of negative number or the imaginary number I. So I hope this video was helpful. I'd like you to now go through some of the student-led examples and see how you do.